Hello, everybody. While somebody is still looking for a seat, I'm going to put this slide here. So basically, with this QR code or that link down there, I hope you can read it. You can follow the slides. There are a lot of code examples. So I tried to annotate all of them. So maybe if there is something that is not really clear, you can look at it afterwards. I hope it's going to be clear then at that point. I'm going to give you a few seconds. Okay, so you are probably wondering, who is this guy? Hello, I am Luciano. I obviously like Super Mario, as you can see there. I work for a company called Vectra, which has headquarters in the States and in Dublin, which is where I work. Vectra is a company that works in the security space, so very convenient if you were here for the previous talk. And basically, Vectra is focused on real-time threat detection. So they use machine learning to figure out if somebody in your corporate network is trying to do something dodgy. You get alerts, and you can immediately figure out what's going on. Aside from Vectra, in the last 2.5 years, probably, I had the pleasure to work with 3 amazing people on 3 different side projects. The first one is a book on Node.js design patterns, together with Mario Casciaro. The second one is a newsletter for full-stack developers, totally free and open source, built on top of serverless technologies, called Full Stack Bulletin, together with Andrea Mangano. And finally, there is Serverless Lab, that me and Patrick O'Brien use it to create open source, basically training courses that you can do to learn serverless on AWS. Here you have all my contacts in case you want to get in touch with me. So what are we going to talk about today? The idea for this talk started when I realized that many developers, especially front-end developers, use tools like Webpack, but they sometimes think that Webpack is something magic, something that just works. Whatever it does, we don't care, we use it, it's fine. And I kind of understand that logic because you cannot really go into the details of everything, otherwise you should have infinite time. But at the same time, I'm kind of curious myself, and I like to understand how things work. And I hope that's the case for you too. So in this talk, I'm going to first show you a sample app and how dependencies affect this app. It's a web app. Then we are going to try to understand what is really a dependency. And then we are going to explore some of the module systems that have born in the history of JavaScript. And finally, how a module bundler can use these modules and do the things that it does. And finally, I'm going to try to explain you what Webpack is and how to use it in just 2 minutes, which is actually very ambitious. So let's see what happens. So this is the web app that I built for fun. It's basically a to-do list. It's actually online, so you can click in the link and use it. It allows you to be very productive and to get poop done. But basically, it's just a very simple web app. You can build something similar in probably a couple of hours. The reason why this app is interesting for this talk is that there are a lot of dependencies in this app, as many other apps out there. The first one is Zepto, just because I think that sometimes React and Angular and all these kind of things are overrated. Zepto is a lighter version of jQuery for those who never heard of it. But basically, I used it in this app just to manipulate the document object model, the DOM, and be able to create elements, destroy them, and attach events and things like that. Then another dependency is this dynamic favicon, where basically you can see a little badge that shows how many to-dos you have left to do. And every time you add a new to-do or remove one, basically automatically updates with a nice animation. And I've done this through this nice library called 5ico.js. Then the other feature is this very nice tooltip with this TPJS library. Then there is another amazing feature. Every time you complete 10 tasks, this happens. Confetti all over. So there is another library for that too. And I can go on. There is local storage. There is UUID for creating the IDs. But the concept is, I created this app. I needed a lot of dependencies. And this is how I wrote my code. So notice here. And you are probably wondering, okay, are you doing really 7 requests only for this little app, only to download the JavaScript? And yeah, this is the current scenario, but it's not ideal, right? What will be ideal? Probably you know this already. If we can concatenate all the content of every single vendor file into one single file called vendor.js, and then just import that. So this way, we basically end up with just 2 requests instead of 7, and all our app code is inside those 2 files. So how do we do that? This is me doing it manually, basically going in every source code and copy-pasting it into the vendor file, right? This is probably not the best way we should do this. It's definitely not maintainable and very error-prone. So I was trying to figure out better ways to do this. And one way is very simple. You just write a bash script where you list all your dependencies. Then you do a little loop. You do a CURL, download the files, print everything, and you have your concatenated file. This is simple, but maybe we can do something better. So I tried, OK, let's try to do this with JavaScript. Maybe I can do something a little bit better. And I created this little tool. Like, you can read this. It's probably less than 200 lines of code. It's on GitHub. But basically, this tool does exactly what I showed you in the bash script, plus some other things. So it allows you to express all the dependencies in a TXT file, like this. So you basically create a file, list all your URL of the dependencies you need, and then you just have to run this command. And basically what happens behind the scene is that this tool is going to download all these files, and it's going to keep also a local cache in case you want to download them again. And then it's going to take the content, concatenate them in the order you specified, and finally it's going to combine all of them and minifying using Babel minify. And finally, you get the result of all this operation as a vendor.js. So basically, this is cool, because we are able, with this simple tool, to move from 7 requests to just 2. And actually, all the vendors are even minified, so we get this extra advantage. So yeah, concatenation and minification for the win. So OK, now I'm thinking this is good. So I've done my job, right? Well, probably not. This was probably good about 10 years ago. And today, I think we have stricter requirements. We want to do things in different ways. And this is what I think we should really have today when we build web apps. We want to do things like being able to update dependency in an easy way. So you have to have commands or tools that allows you to tell you, OK, now I want to use the latest version of jQuery, React, whatever is your tool of choice. Then there is also another problem that I didn't really explore in this app because it was simple enough. But in real apps, you might have this problem. What if jQuery requires me to have another library installed and instantiated before jQuery actually runs? So you start to get into this loophole of dependencies of dependencies. This is something I don't want to manage as a developer. And also, the thing is, if you start to think this way, you also have to worry about the order of importing your requirements, right? So if jQuery needs to be there before I run this code, then I have to be very careful where I put my jQuery script, right? We don't want to worry about this as well. So let's try to figure out what a dependency really is. For Wikipedia, dependency is a state in which one object uses a function of another object, which, to put it more simply, I think is when you have an object that needs another object to do its job. But very often we talk about something that is called reusable dependency. So when you have a dependency that you want to use in many projects maybe, and that's what we generally call a module. Or to try to give a better definition of it, a module or modules are the bricks for structuring non-trivial application, but also the main mechanism to enforce information hiding by keeping private all the functions and variables that are not explicitly marked to be exported. Very long definition. I just want to stress 2 concepts: information hiding and exported functionalities. But before we move on to some more things, let me introduce this guy, my friend. Some people call him Iffy, I think is the most common name. But basically, his name, IIFE, means immediately invoked function expression. So before really explaining you what this guy do, let's see how we generally define a function in JavaScript. We can do it this way by using the short arrow syntax, or we can do it with the long version where we just say function name, arguments, and then a body. And then when we create this function called sum, at some point in our code, we are going to execute it this way, right? This is very simple stuff if you ever wrote a line of JavaScript. So the thing about functions in JavaScript is they create an isolated scope. So if you write a code like this, look at the secret string in there. That string is going to be visible only inside the function and not outside. So now again, here we have a function. This function is accepting 2 arguments, and it's going to create some kind of isolated variable inside the scope of this function. What happens when we start to use iffy is that we can wrap this function with this code out here. And basically what is going to happen is that all the expression that you see inside gets resolved as JavaScript as a variable that is not assigned to anything. And this variable is actually a function. So when you wrap it this way, you are basically telling the JavaScript runtime, run the function that there is inside. And actually you can even pass parameters from the outside. So this is what iffy basically does, allows you to create a self-executing function with its own isolated scope, and you also have the opportunity to pass arguments from the outside scope. And why it is important, we will see it in a moment, because this is a very recurring pattern when we talk about modules in JavaScript. So, okay, now that we know iffy, let's try to implement our own version of modules in JavaScript and trying to stress the goal of the module in providing information hiding and exporting only specific functionality. So we can see this example where basically I have a module here and then some code underneath using the module. So in this module, you can immediately notice we are using this iffy expression, right? Then inside the module, in the body of the module, we are declaring some private stuff. And this is the information hiding part. We are never going to expose outside the module itself this kind of variables in there. Then at some point, we start to define the actual functionality that we want to expose to the outside world. And we call it exported. But this is not really exported until we actually return it from this scope. When we return it, what happens is that this thing moves to the outer scope and gets assigned to my module, because we are basically assigned the result of all this iffy as my module. So when we run this code, then in our main application code, we are able to do things like this, my module.public foo, and we are actually using the exported functionality. But at the same time, we are not able anyway to use the private stuff. So we don't see private foo, neither by doing my module.private foo or trying to access it directly with private foo. Okay? So when we talk about modules, often we think, okay, I want my module to be reusable because I'm spending a lot of time building this module and maybe I'm going to need it in my next app. So how do I make it so that I can reuse it over time? Or maybe I can share it with my colleagues too and get some of their work as well. So to do that, we need a standard module format. And what are the expectations for a standard module format? So the first thing is that it needs to be simple enough as a developer to define the import and the export statements. Then it needs to provide information hiding, because this way we can have a clear contract with the people using the module. They are going to get only the feature that they need, and they are not going to try to change the internals. And then we need to be able to define modules in separate files, just because it gets easier. You don't write everything in one big file, and then it gets very easily out of control. Then we want to do other things, like a module needs to be able to import other modules and deal with nested dependencies. Also, there are other things that I think would be nice to have, like the ability to import only subsets of specific modules. Imagine you are using Lodash. Maybe you just want to use one function and not all thousands of them. I don't know how many. And then you want to avoid naming collisions. You want to do asynchronous module loading. And also it would be very nice if you could have something that works straight away, both on the server side and the browser side. But you know, when we talk about standards, this thing very often comes up. And if you never saw it, basically means, okay, if we have 14 standards, somebody at some point is going to say, oh, let's create a better one because all the other ones suck. So we can do better. And then eventually you just have 15 competing standards. And this is also JavaScript, so you expect nothing else than this, right? This is what we have right now and probably even more. And I don't think I know all the possibilities there. But these are definitely the most famous JavaScript modules out there. The first one that has been there forever is the global. Then we have CommonJS, IMD, UMD, ES 2015, and again, many, many others. So I'm going to try to describe very quickly all of them. I don't expect you to follow all the details, so I really encourage you to go back and check the slides if something is not clear. But the point is just to try to understand some of the patterns, because we will see them again when we explore module bundlers. So the global one is very simple to the one we just saw before when we try to implement our version of a module system. We basically just say, okay, this is jQuery, assign it to, in this case, 2 variables. So we are going to have this library called either $, or jQuery. And then inside of it, we will have all the functionalities exposed by jQuery. So at some point, we can say $.find and actually use jQuery, right? So that this variable $, and jQuery, they will be available all over in our app. We can use them anywhere. We have no way of scoping this out. So the issue is that you might generate naming collision, right? And maybe some of you knows that browsers like Chrome, they already have an internal feature that is called $. So if you use jQuery, you might override that feature. And this might happen, of course, with other libraries, so you have to be extra careful on how you name your libraries and which libraries you import if they are global. And the order of imports is important, because if you want to rely on jQuery, you need to make sure that it has already been exported in the global scope before you use it. And finally, you cannot easily import just a single part of jQuery. Let's say you just want the functionality, I don't know, find. You cannot really do that. You have to import the full jQuery. So now let's see CommonJS. I don't know why we see those scroll bars there, but I hope it's readable. Anyway, CommonJS has been popularized by Node.js, and it has a very simple and straightforward syntax. So there are 2 things to notice. If we have a module, we basically define the functionalities inside, and then we basically just say modules.export to indicate what is the part that you want to make public. Finally, in your app code, you are going to use it either this way by saying require and the name of the module, or by requiring just a subpart of it, in this case concat, by using the structuring operator of JavaScript. So why CommonJS is slightly better? Because it allows you to redefine the name of the modules you import, so you avoid naming collisions. Then there is a very, very big repository with probably millions of modules you can already use today with NPM, and almost all of them exposes the modules with CommonJS format. And then the issue that we have with CommonJS is that since it was built for the server side, it's synchronous. So it's trying to read files and not doing HTTP requests. So they don't care for the module system to be asynchronous. And it works natively because of this reason, only Node.js and probably some other server runtime. So at this point, we can see AMD that actually tries to solve the problem of synchronous module loading. AMD looks like this. You have a function. This is how you define a module. You have a function. You use this constructor with define. You say what is the module name as the first argument. Then if this module relies on other modules, you define them this way. And finally, you have a factory function. And these factory functions will receive from the runtime system all the dependencies injected in it. And then finally, what do you want to export? You return it from this factory function. The way you use require.js, it's a bit verbose. So basically, you have to tell, since this is going to work in the browser, you have to tell the browser where to find the files. In this case, if we want to use jQuery, we have to tell the browser, OK, when you use AMD, if I'm telling you to load jQuery 1.9, then this file is going to be in the folder JS_lib in the current domain. Then when you do that, you can actually use jQuery in your app by just creating another AMD module that actually is the main one that is going to run and get jQuery as a dependency. So AMD is very cool because it's asynchronous and you can use it either in the browser and in the server. But my opinion is that it's a bit verbose and sometimes it's very hard to write the modules and you have to remember all this convoluted syntax. But that's just my opinion. Maybe other people will find it easy to remember. So at some point there is UMD. And I think the history of UMD was probably started by the guy that created one of the first promises libraries called Q. I think it's called Chris Cowell, where he basically tried to figure out a way to say, OK, many people are using many different module loaders. I want my library to be compatible with all of them and write it in a way that I don't have to create 3 separate files for 3 different module loaders. So he figured out this very, very clever way of doing that. So there is an iffy again, and inside this iffy, we are passing as argument to the main function this, which basically represents the scope where you are running this code, and then a function that is actually the factory function that is going to define the content of your module. So all the code for your module is going to live inside this function. And if your module will need dependencies, they will be injected there in the function as arguments. Then inside the main body of the iffy, we have several if conditions. And basically, these if conditions are trying to figure out which runtime you are using. So if you're using CommonJS, you will have module.exports. Then you can basically use the factory and assign it to module.exports. Same with define. If you have define, you are probably using AMD. So let's use AMD to export the functionality of my module. And then finally, if none of these two are used, you are probably using global. So let's assign the global variable my module to the result of the factory function. So UND, again, is very cool and very clever, but I don't expect anybody to write all that boilerplate code by hand. So every time you have to have some build process that will do all of that for you. So it's clever, but yeah, you have to automate it. Then there is this new thing, relatively new now because almost 3 years passed since 2015. So basically, this is a new syntax that aims to be very simple, but at the same time very powerful. And it's simple because you just have to remember 2 things. That to export a functionality, you just use export, and you can pass either a single functionality or an object with many functionalities. You can also do other things like use defaults, but that's a detail for now. And then when you want to import one of the features of the module, you can just do import specific feature from a specific module. So you have to remember just export and import. And this thing kind of work in the browser too. We are getting there. It's not ready in all the browsers, but many browsers today already support this syntax that allow you to import modules with this syntax directly on the browsers. So it is kind of similar to CommonJS from a syntactic point of view. You use import and exports, but the interesting thing that is very often underlooked is that import and export are static, so there is a big difference in there. When you use CommonJS, everything you write inside a require can be an expression and it's going to be evaluated at runtime. With this syntax here, you only have strings to indicate your modules. So it's something that can be, the dependency graph, which we will see later on, is something that can be built even without evaluating all the code in your JavaScript modules. And this is very powerful, but I'm not going to go really into these details. I'm just giving you an advice to go and try to figure out this one better, because it's going to come up a lot in the next years. There are 2 kind of things, and are that it is a very cool format, but it's still a work in progress, so it's still going to take a while before we can use it confidently. And also works almost seamlessly on browsers and servers. And again, I'm not going to tell you all the details because I can do another talk on that. Probably I'm not the right person, but somebody can do an entire talk on that and it's going to take probably 1 hour. So if you are interested, I encourage you to read some of these links and you will find a lot more than I can say here in 40 minutes. So yeah, there are so many options. What do? We have to pick one eventually, right? And I can tell you that the most common choices are to use CommonJS or ES 2015, and then in order to use those functionalities properly in the browser, we use something called module bundlers, and that's actually the goal of this talk. So what happens instead if, I already told you this is not going to work, but what happens if we are still stubborn and we want to try to just use require in the browser? So this is what happens. Actually, the first line of my code is going to fail just because, yeah, the browser is going to tell me, okay, what is this require you are talking about? I don't know anything about it. So module bundlers allows us to use require and build our code in a way that the browser will be able to understand. Or in other terms, a module bundler is a a tool that takes dependencies written in the form of CommonJS or ES 2015 and emits a static asset that can actually be run in the browser. To understand how it works, I mentioned this before, but we have to understand how a dependency graph works, or what it is first. So dependency graph is basically a graph that is built by connecting every module with the modules that it is depending upon. So in this case, we have app that is using dependency A is using dependency A2, and so on and so forth. You can also have shared dependencies. That's why it is a graph. Then the role of a module bundler, it's actually double. It needs to first build the dependency graph by exploring all your code. And second, it needs to assemble all the code that was found in this graph in something that can actually be run in the browser. So let's have an example. I hope you can read it. So basically, this is a very simple calculator app. It's just to show you different modules. So the first module is what we call entry point, which basically means this is the file from which we start to look for require statements. So we start from this file, and the first line we find is this one, require calculator. So while we resolve the dependencies, we have to jump inside the calculator file and look for other requires. So the next require we find is parser. Then we jump again into parsers, and we keep looking for other require. There is none, so we can go back and we find resolver. Then we jump to resolver. There is again no require, so we can jump back to the app. And then we find log, and so this way we built the entire dependency graph. So while the module bundler is visiting your code this way, internally it's actually creating a modules map. And a module map looks like this. So it's basically an object where for every dependency it's going to create a record. And every record looks like this. You have as a key the required path for that module, and as a value, what is essentially a factory function for that module. And this factory function is written with this signature, module and require as arguments. And then inside the three dots there that I just put there to say, there you have all the code for that module. Basically, you will have something that when you execute it is going to run all the code for your module. The interesting part is that you are accepting as argument a function called require, and another thing called module. So basically, all the requires and the module you use inside your actual code are something that can be rewritten from the outside world. That's the tricky part to understand. So once we have the module map, we can actually convert it to code that is executable by a browser. Let's see how to do that. That's the interesting part. So again, we have an IFI. And this IFI is actually passing to the main function this modules map. Then inside this IFI, we are redefined the require function. And the goal here is not to require from files as we do with CommonJS, but to require from this actual modules map. So in this function, once we define require, inside this require, we create for every module that we are trying to require, and there you receive the name of the module, we have to define an object that just contains module exports, but at the moment it's just an empty object. So you will only have the exports key. And then at that point we say, okay, you are trying to load a module called, in this case, variable name, so I'm going to just use the map to get the name. This is going to give you the factory function, and then you are going to pass the current module and require, so that the modules can actually import other modules if they have to. So this is essentially the, if you are somebody interested in design patterns, this is essentially the service locator design pattern, right? We have a map with all our services. They are mapped by name. So at some point we say, okay, I want this service. And that's what happens. It gets created by a factory. So when you run all this code, you're basically running the code for a module, and you are receiving a module.export. The code is going to fill in all the values, and then at that point you can return it to the outside world. And that's how you require a single module. Just to get the process started, you are going to require your entry point, which is our app file, and that is going to trigger all the other requires in the chain. So yeah, this was my reaction the first time I tried to understand this. So if it's not clear, if you look at it other 2 or 3 times, at some point it's going to become clear and probably not magic anymore. That's what I hope, at least. Okay, so now we know how a module bundle works, how to explore the dependency graph, and how to transform the modules map into something that can be executed by the browser. So I have a challenge for you at this point. Can you build a module bundler yourself? Now you know all the theory. It shouldn't be that crazy difficult, right? And I can give you a few tips, but I'm going to leave it to you to read the tips only if you want, okay? If you want to entertain this challenge. Of course, even if you succeed in this challenge, I don't expect you to use your module bundler in production. And the only reason is because there are already tools out there that hundreds of people are building and thousands of developers are using every day. So it's very likely that they are going to be more stable and they will have more features that you can ever build in a lifetime. So use the proper tools. But if you did the exercise, you will really understand how to use the tools. So one of the tools that is probably the most mainstream at the moment as a module bundler is Webpack. And I'm going to try to explain it in just 2 minutes. So it's a big challenge for me at this point. But yeah, basically Webpack is just another npm module. So you install it by saying Webpack and Webpack CLI, npm install. And then at that point, you just have to run Webpack and app.js. And this is actually something quite recent, because before you needed to write a configuration file. Now if you just run this code, it's going to work with most of the apps straight away without configuration. There is a cool trick that you can do. You can add this extra parameter and say mode development. And this is basically going to instrument Webpack to run the development mode. And this is not going to minify your bundled file. And it's actually going to add a lot of comments that will make you understand how the module bundler actually works. And here you have an example. I'm not going to go in detail of this file, but you are probably going to find all the patterns that we discussed before. Of course, there is a lot more because Webpack takes care of things like caching the modules and not running them every time they appear again. But you will find all the fundamentals we just discussed in this file. So I really encourage you to take your app that you are working right now and do this exercise to see if you can understand the bundled file. So some Webpack concepts, because you can use Webpack without config, but it's very, very likely that at some point you will need to write custom config for that. So the key 4 points are entry point, and we already know what that is. It's basically just the first file that we start to analyze. Then there is output, which is basically where do we want to save our resulting bundle file. Then we have this concept of loaders, and this is something that is very cool and kind of unique of Webpack. So basically, you try to do something that builds a JavaScript file, right? But all the source file, they don't necessarily need to be JavaScript files. Or they can be dialects of JavaScript, so to speak. You can use, I don't know, TypeScript, or you can use future versions of JavaScript using Babel. Loaders allows you to tell the module bundler how to load the source files and how to convert them into something that is actually runnable in the browser. So examples might be Babel, TypeScript, ClojureScript, or things like that. And then finally, we have a concept of plugins that allows you to extend the work that the module bundler is doing and do extra things, like, I don't know, creating a gzip file for every resource that is created, or maybe do dependency analysis and give me an output where I see how much space is every module taking of the final bundle. So this is an actual more realistic configuration file that is using Babel, which is probably one of the most common things these days, especially if you are using React or tools like that. So basically we have an entry point. Then we have this output that is essentially saying, I want to save the resulting file in build app. And then there is this very verbose syntax that you very often just gonna copy paste from somewhere else. But if you want to understand it, it's not that difficult. It's just saying for every file that ends with .js, I want to use Babel to convert it into something that is actually runnable as JavaScript. And finally, here we are using a plugin, and specifically, I'm using a plugin to create gzipped file for every resource. So in reality, you can do a lot more with Webpack, and that's one of the reasons you should use it. You can create dev servers to help you while you are developing the app. You can do tree checking, which is another very cool feature that allows you to remove the parts of modules you are not really used from the final bundle. So it's going to help you to get very small bundles. And then you can do other things like dependency analytics, produce source maps, do async requires or module splitting. So this is why you should really look into Webpack and start to use it and understand it better. So now at this point, I'm almost done, and I think you understand at least the basics of how a module bundle work. You don't think they are really magic anymore, I hope, right? And yeah, my advice is that you start small and you try to build on top of it. If there is something you don't understand, just try to look for an abstraction. But at some point, please come back and try to figure out how it really works, because it's going to help you in your career and in building better apps. And yeah, if you try to build your own module bundle, you're going to learn a lot of things, not just about module bundlers, but of JavaScript in general. So I encourage you to do that exercise. And this is me done. Thank you.